So in this video, we're going to go over the nature of roots for a quadratic equation. And to do so, let's revisit our standard quadratic equation. Ax squared plus bx plus c. So equals to 0. Equals to 0. So we want to find the values of x that solve this equation. Well, we know that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula. And to determine how many solutions do we have, right? If you want to know how many solutions we have, we want to check the term inside our square root, b squared minus 4ac. That is very important. And we have a special name for this. So we'll represent it with a triangle or with delta sometimes, but this is known as your discriminant. And the discriminant tells you something about how many solutions or how many roots you have. So let's consider situation 1. b squared minus 4ac is bigger than 0. Well, if you have anything that is bigger than 0 inside your square root, you can take the square root. So in this case, you have 2 solutions. And if you go back to so if you assume that this is your quadratic equation, then your graph looks something like this. If a is positive, then it intersects twice, right? So if a is positive, then it cuts your x-axis 2 times. If a is negative, it cuts like this. So this is for a bigger than 0, this is for a less than 0, right? So basically, your quadratic equation is going to cut 2 times if you have a discriminant that is positive. If b squared minus 4ac is equal to 0, you have exactly 1 solution. And 2 solutions means we have 2 distinct roots. And in this case, we have 1 repeated root, or 1 repeated solution. And the graph looks something like this. So if a is positive, you have a graph that looks something like this. It can be translated anywhere on the x-axis, by the way. Or if a is negative, it looks something like this. And finally, if you have b squared minus 4ac less than 0. So if you have the square root of a negative number, does not have a solution, at least when we're talking about real numbers, right? So without involving complex numbers, we can't really solve that equation. So basically, if b squared minus 4ac is negative, if the discriminant is negative, we have no solutions. So your graph probably looks something like this if a is positive, or it looks something like this. Sorry about that. This if a is negative. So it does not cut your x-axis at all. So we have considered the 3 cases, right? We looked at the discriminant. We know when we have 2 solutions. So if we have 2 solutions, then what are your solutions? So in the case of 2 distinct roots, which is where b squared minus 4ac is bigger than 0, then you have x1 is equal to minus b plus square root of b squared minus 4ac over 2a, and x2 is equal to minus b minus square root of b squared minus 4ac over 2a. So those are going to be your 2 distinct roots. And when you have only 1 repeated root, then your solution is going to be at the vertex. So your x is going to be minus b over 2a. Why? Because b squared minus 4ac is 0, right? So square root of 0 is just 0, so you have minus b over 2a. So that is about it. And now we are ready to start doing some questions. All right. So find the discriminant of each equation, and hence decide if the equation has two distinct roots, two equal roots, or no. So two equal roots is the case of one repeated root, right? Equal means you have the same root that is repeating, or no real roots. So why we say no real roots is because if you have square root of something negative, then, well, if we are talking about complex numbers, then we can write something in terms of the imaginary number I. But there is no solution when it comes to our real numbers. So everything, when we are talking about real numbers, which we will be for most of the topics related to the grade 11 syllabus, so there is no real solutions here. All right, so part A, b squared minus 4ac, negative 12 squared, right? So let me just do it. Let's make a very small space here to do it. A. So b squared is negative 12 squared, right? B squared minus 4, a is 1, and c is 36. And basically, if you solve that, you have 144 minus 4 times 36. And that is 0. So the discriminant is 0. So delta equals to 0. That means you have one repeated root, or two equal roots. So you have two equal roots or one repeated root for A, because discriminant is 0, right? For B, b squared, so 5 squared minus 4 times 1 times negative 36. So you want to take the sign as well. And that is going to be something bigger than 0 if you solve it. So this one has two distinct roots. So delta is positive, you have two distinct roots. The first one has two repeated or two equal roots. So basically, you have two equal roots just means you have one repeated root. And for B, you have two distinct roots. So we are done with A and B. So this one has two equal roots, or what we call one repeated root. B has two distinct roots. Let's look at C. So C is just 9 squared minus 4 times 1 times 2. 9 squared minus 8. This is bigger than 0. This is bigger than 0. So this one also has two distinct roots. All right. So 4, b squared. So minus 4 squared is 16 minus 4 times a is 4 times c. So this is 0, right? So this has two equal roots or one repeated root, however you want to say it. So e, minus 7 squared is 49 times 4 times 2 times 8. So 16, 4, this is less than 0, I think. And basically this has no real roots for E. And for F, b squared is 100 minus 4 times 3 times negative 2, right? Negative 2. So this is positive, so this has two distinct roots once again. All right. So we are done with part 1. So use the discriminant to determine the nature of roots of this equation. Well, we don't want x in the denominator, right? So we multiply by x on both sides. Times x. So now we get 2x minus 5x squared equals to 4, because these cancel out. And basically, if I bring everything to one side, I have 5x squared minus 2x plus 4 is equal to 0, right? If I add 5x squared on both sides, I get 5x squared plus 4 is equal to 2x. And if I subtract 2x on both sides, I get this expression. And now I can do minus 2 squared, like b squared, minus 4 times a is 5 times 4. And this is less than 0. So this equation has no real roots. So if you put it in your calculator, you will see that this expression is negative. And if the discriminant is negative, we have no real roots. So we are done with 2. All right. The equation, this equation, has roots 5 and 7. So find the value of b and find the value of c. There are a number of ways to approaching this question, but the easiest way would just be to substitute it. So substitute 7 in the equation. 49 plus 7b plus c is equal to 0. So 7, because 7 satisfies this equation, right? So 7b plus c is just negative 49. That is equation 1. And now substitute negative 5 into this equation. If you do so, you'll see that you have 25 minus 5b plus c is equal to 0. So you will see that you have 5b plus c is equal to negative 25. And from the first equation that we had was 7b plus c is equal to negative 49. And you can subtract these two equations. Why? Because c minus c cancels out. So minus 5b minus 7b. So you can solve the simultaneous equation. Get minus 12b is equal to negative 25 plus 49. So that is 24. So b is just negative 2. And you can substitute b into any one of the two equations. So 7 times negative 2 plus c is negative 49. So c is just negative 49 plus 14. So you will see that c is negative 35. And you're done. You've calculated the value of b and you've calculated the value of c. Negative 2 and negative 35. All right. So you're done with 3. Question 4. Find the values of k. So we won't do all of the questions. So for 4, we will do B, D, and F. And for 5, we'll do A, C, and E. So just half of each. All right. So we want to find the values of k for which the following equations have 2 equal roots. So basically, this is the case of repeated roots, right? 1 repeated roots, which we say the discriminant is equal to 0. All right. So for B, we have 4x squared plus 4k minus 2 x plus k is equal to 0. All right. So b squared, this is b squared, right? What is b? B is the coefficient of your x term. So bk minus 2, b whole squared minus 4, a is 4, c is k. So you want to identify a, b, and c. First of all, a is 4, b is 4 times k minus 2, and c is k. And you want to use b squared minus 4ac is equal to 0 because your discriminant has to be 0. So this expression has to equal to 0. So 4 squared, that is 16 times k minus 2 squared minus 16k equals to 0. Right? And now you can solve this equation. 16 k minus 2 whole squared, that is k squared minus 4k plus 4 minus 16k is equal to 0. Both terms have a factor of 16, so you can actually divide by 16 and you get k squared minus 4k plus 4 minus k is equal to 0. So I just divided by 16 on both sides. 0 divided by 16 is still 0. So k squared minus 5k plus 4 is equal to 0, and this is a quadratic equation, so you know how to solve this. And I'll solve it by factorizing. So I think it's k minus 4, k minus 1 are the factors. So k is equal to 4 and k is equal to 1. For these values of k, for 4b, k is 4 or k is equal to 1. That values of k will give you a quadratic equation that has 2 equal roots or 1 repeated root. All right. So we'll use the same idea again. For d, we have x squared minus 2x plus 1 is equal to 2k, k minus 2, right? So I'll leave a, c, and e. The idea is same. B squared minus 4ac has to be equal to 0. So we have x squared minus 2x plus 1 is equal to 2k, k minus 2. X squared minus 2x plus 1 is equal to 2k squared minus 4k. All right. And we want to bring everything to one side, right? So x squared minus 2x plus 1 plus 2k squared plus 4k. That is equal to 0. And now we want to group it, right? This is c, because all the constant term is just c. Sorry, this has to be negative, I believe. Yeah. It's minus, because if I bring this to the left-hand side, it minus 2k squared plus 4k is equal to 0 if I've done everything correctly. I think I have. This is b, minus 2 is b, and a is just 1. So minus 2 squared, b squared minus 4a, and c is just this ugly expression. So 4 minus 4 times 1 minus 2k squared plus 4k. And we can divide by 4 on both sides. If I divide my first term by 4, I get 1. And the second term divided by 4 just leaves whatever I have inside the bracket. And 0 divided by 4 is just 0. So 1 minus 1 is 0. And then I'll get 2k squared minus 4k. And I can factor out the 2k. I get k minus 2. And from this, I get k is equal to 0. So if I put k 0, then I get everything 0. Or k is equal to 2. So that should be my solution. K0 or k is equal to 2 should be my solution for part D. Alright, now let's move on to part F. The idea is very, very similar. Again, we have 4x squared minus k minus 2x plus 9 is equal to 0. So b is just this expression. Minus k minus 2, b squared minus 4, a is 4, c is 9 is equal to 0. The discriminant is equal to 0. So I have k minus 2 whole squared minus 16 times 9, right? That is 144. Alright, so k squared minus 4k plus 4 minus 144 is equal to 0. And k squared minus 4k minus 140 is equal to 0. And we can solve this equation. K is just going to be, if I use the quadratic formula, I'm going to get 4 plus or minus the square root of 16 minus 4 times 1 times negative 140 over 2 times a is just 1, right? So I'm solving this quadratic equation in terms of k. So I have 16 minus 4 times a times negative 140. So 576, right? And the square root of 576. So you have 576 here. And 4 plus or minus, the square root is just 24. So 28 by 2. So k is equal to 4 plus 24. 28 by 2 is 14. Or k is equal to negative 10. Those should be your two solutions for E. Negative 10 and 14. Yep. Alright, so I'll leave A, B, and C, A, C, and E for you to try. Alright, so now find the values of k for which the following equations have two distinct roots. Two distinct roots just means delta is positive. Two distinct roots means your discriminant is bigger than 0. So for A, we have x squared plus 8x plus 3 is equal to k. I want 0 on my right-hand side. So I bring everything to one side. Plus 3 minus k. That is my c. This is A. This is B. This is my c. Alright, so b squared minus 4ac has to be bigger than 0. So b squared. 8 squared is 64 minus 4a is 1. c is 3 minus k. 64 minus 4 times 3 minus k is bigger than 0. So 64 minus 4 3s are 12 minus 4k. That is bigger than 0, right? So 64 minus 12, that is, I believe, 52 plus 4k is bigger than 0, right? If I subtract 52 on both sides, I get 4k is bigger than negative 52. So k has to be bigger. So negative 52 divided by 4. I can divide by positive 4 without changing the inequality sign. So k is bigger than negative 13. That is my solution for 4a. 5a, sorry. For c, it's the same idea. We have kx squared minus 4x plus 2 is equal to 0. So b squared minus 4 squared, that is 16, minus 4. A is k, c is 2. Sorry, this has to be bigger than 0. So 16 minus 8k has to be bigger than 0. If I add 8k on both sides, I see that 16 is bigger than 8k. I can add or subtract without worry, and I can divide by positive 8 without worry. So k has to be less than 2. That should be my solution. So 2 bigger than k or k less than 2 is my solution to C. All right. And for part E, I have 2x squared is equal to 2x minus 1 plus k. 2x squared is equal to 2x minus 2 plus k. 2x squared minus 2x plus 2 minus k. So I bring everything to one side, I get this expression, right? So this is A, this is B, everything here is C. B squared minus 4AC has to be positive. So minus 2 squared minus 4 times A is 2, C is 2 minus K is positive. 4 minus 4, 2 times 2 minus K. I can divide by positive 4 without worry. So 1 minus, so divide by 4, 4 divided by 4 is 1, and 4 divided by 4, I just have 2, 2 minus K is bigger than 0. So I have 1 minus 2 2s are 4 minus plus 2K, I believe, is bigger than 0. So 1 minus 4 is negative 3. And if I add positive 3 on both sides, I get this expression. K just is bigger than 3 over 2. That is, I believe, my solution. All right, so because I can divide by positive 2 without an issue. So for part E, it's K bigger than 3 over 2. All right. So if you think that these were a bit too easy, let me do F as well. And I believe the rest is pretty similar. So B looks very, very similar, and D looks very similar to F. So let me do F as well. 2k minus 5. This is B squared minus 4. A is K. And C, okay, so this is not in the standard form. Sorry about that. Kx squared plus 2k minus 5x. And I want to bring this expression here, right? So minus 1 minus k. So I just put this in bracket and I subtract it on both sides. I get this expression. So this is my C, this is my B, this is my A. So instead of bringing these two terms individually, I just put them in a bracket, I bring them together, and I put a minus sign in front. That is okay. B squared minus 4AC is bigger than 0. So 2k minus 5 squared minus 4k, because A is K, and C is negative, right? Negative 1 minus K is equal to 0. Remember, C you have to take with the sign in front, which is negative here. All right, so 2k minus 5 squared, that is 4k squared minus 20k plus 25, I believe. 4k squared, yeah, minus 20k plus 25 minus 4k, and this is just k minus 1. So it's bigger than 0. Bigger than 0. So if I simplify, I have 4k squared minus 20k plus 25 minus 4k squared minus 4k, right? If I multiply 4k inside. 4k squared minus 4k cancels out. Minus 20k minus of minus 4k. So I have minus 16k. Because minus of minus is just plus 4k. Minus 20k plus 4k is minus 16k plus 25. Let me add minus 16 on both sides. So 25 is bigger than 16k. So you only want to divide by positive numbers. That is why instead of taking 25 to the other side, I took 16k to the other side, right? So now I can divide by positive 16 without having to worry about my inequality. So that should be my solution. K is less than 25 by 16. Yeah, K is less than 25 by 16. That is my solution. So that is F. And you can try D. It's just solving the quadratic inequality, which we have discussed in the previous video. All right. So we are done with 5. K less than 25 by 16. Yeah. All right. Moving on. So find the values of K for which the following equations have no real roots. And that means B squared minus 4AC is less than 0. So that is what we're trying to solve here. The discriminant is less than 0 if you have no real roots. So let me just pick D, B, and E. And I think A, C, and F, you can very well do it on your own. So B is 3x squared plus 5x plus K plus 1. So that is C, right? So this is A, this is B, K plus 1 is C. b squared minus 4ac is negative this time. So b squared, 5 squared is 25, minus 4, a is 3, c is k plus 1, less than 0. So 25 minus 12k plus 1 is less than 0. 25 minus 12k minus 12 is less than 0 because I have to multiply inside by 12 and I have to distribute this negative sign as well. All right. So now 25 minus 12, that is 13 minus 12k is less than 0. If I add 12k on both sides, I get 13 less than 12k. And if I divide by 12 on both sides, I get 13 by 12, k bigger than 13 by 12. That should be my solution. K bigger than 13 by 12. All right. So that is my solution for B. For D, I have 2x squared plus k is equal to 3x minus 2. And the idea is simple. Bring all the terms to one side so that I have a 0 on the other side. 2x squared plus k is equal to 3x minus 6. 2x squared minus 3x plus k plus 6 is equal to 0 if you bring these terms here. So this is A, this is B, this is C. All right. So minus 3 squared minus 4ac is less than 0. That is the discriminant. 9 minus 8k plus 6 is less than 0. 9 minus 8k minus 6 eighths of 48 is less than 0. So 9 minus 48, that I believe is negative 39 minus 8k is less than 0. So if I send 8k to the other side, negative 39 is less than 8k. And therefore, negative 39 by 8 should be less than k. So that should be your solution. Usually, it's better not to try to divide by negative numbers when you're dealing with equality. So k bigger than negative 39 by 8 is your solution to D. All right. And finally, we have E. So E just says I have kx squared plus 2kx is equal to 4x minus 6. Kx squared plus 2kx, if I bring this here, I have minus 4x plus 6, right? If I bring 6 as well. So kx squared, now I have 2x terms. So let me just write it like 2k minus 4x, right? I can do this. Plus 6. And this is my A, this is my B, this is my C. All right, so b squared minus 4ac is less than 0. B is 2k minus 4 squared minus 4. A is k, C is 6, is less than 0. Now if I expand my first term, right, I have 4k squared minus 16k plus 16 minus 6 fours are 24k is less than 0. All right. So 4k squared minus 16k minus 24k, that is minus 30k. Minus 16 minus 34. Sorry, minus 24. That is minus 40k, sorry. Minus 40k and plus 16 is less than 0. I can divide everything by 4. So I get minus 10k plus 4. And I can factorize this. And when I factorize it, I believe I get... I don't think I can factorize this, actually. So did I make a mistake somewhere? Let me think. So I want two numbers whose product is 4 and sum is negative 10. That's very hard to achieve. So minus 4x plus 6, everything looks okay, actually. So let's just try to find the roots of this quadratic equation. So k is equal to minus 10, right? So that is 10 plus or minus the square root of 100 minus 4 times 1 times 4. So that is just 16 over 2. So k is 10 plus or minus the square root of 100 minus 16. That is 84 over 2. Now 84 is just 10 plus or minus 2 root 21. I can write 84 as 4 times 21, and then 4, when you take the square root, is this. I have 10, so I have 5 plus or minus square root of 21. Alright, so 5 minus square root of 21, that is still positive, right? So I believe you have 5 plus square root of 21, 5 minus square root of 21, and you should have, if you put anything bigger than 5 minus plus square root of 21, I think it should be plus minus plus. You can pick values. So one value that is bigger than 5 plus square root of 21, that is 10. 10 is bigger than that. So if you put k is equal to 10, 100 minus 100, 100 minus 100 plus 4, that is positive. If you put 0, you get positive. And yeah, so it's plus minus plus. So you can just pick values and see. So if you want, so if we want, right, this to be less than 0, what values of k do we need to pick? We need to pick k values in between here. So if we pick 5 plus or minus square root of 21, we get 0. So our k value needs to be in between 5 minus square root of 21 and 5 plus square root of 21. All right. So this was a bit difficult, I believe, but it's not that hard. So you just find the square roots, you just solve this inequality, and then you just check the condition, and you get this answer. All right, so we are done with part 6. Part 7. This equation has repeated real roots. Repeated real roots, two same roots, double same roots, the same thing. Find k in terms of p. So so if you have two repeated real roots, then we have b squared minus 4ac is just 0. And then we just substitute. B is p squared minus 4, a is k, and c is 5. So we have p squared minus 20k is 0. And find k in terms of p. So 20k is just p squared, and k is 1 over 20 p squared. That is what they want. K in terms of p is p squared by 20. So this is your answer. And we're done with 7. All right. Question 8. So find the range of values of k for which this equation has real roots. So basically, if you want real roots, you can have repeated roots, or you can have distinct roots, right? You can have 2 distinct roots, you can have 2 repeated roots. Those are all real roots. So the condition here is actually b squared minus 4ac is bigger than or equal to 0. We just don't want it to be negative. All right. So this is b, right? So negative 5 squared is 25 minus 4, a is k, c is 2. 25 minus 8k is bigger than or equal to 0. If I add 8 on both sides, I get 25 is bigger than or equal to 8k. And 25 by 8, so this is the condition on A. So k is less than 25 by 8. That is it. So you just want to analyze what the question is asking you. You want to know the condition, and then you want to solve the question. All right, so question 9. Prove that the roots of the equation are real and distinct for all real values of k. All right, so let's just look at the discriminant of the equation. B squared minus 4ac. B is 5, so 5 squared is 25, minus 4, a is 2k, right? A is 2k, c is negative k. That is our discriminant. So 25, I have minus of minus, that gives me plus 8k squared. So we have 25, 4 choose 8, 4 choose 8k times, yeah, 25 plus 8k squared, I believe, if I did the calculation correctly. And if you think about this, right, now let's just remember the graph transformations we talked about. 8 times, this is a. This is the stretching factor we were talking about. So this just makes our graph sharper, right? If this is y is equal to x squared, multiplying by 8 just stretches it. And adding 25 just shifts it 25 units up. So this is our vertical shift. This is our k value. This is the k value that we were looking at when we were discussing about transformation. So our graph looks like this. And if you think about it, the output is actually always bigger than or equal to 25, right? Our bottom point is at 25. Our minimum value is 25. So this value is always bigger than or equal to 25 if you think about it from a translation perspective. So it's definitely, for all values of k, it's whatever k you put in, and you can check. If you put k 0, you get 25, and any other value of k, you're going to get an answer that is bigger than 25. So for all k, the discriminant is bigger than 25, bigger than or equal to 25, which implies that the discriminant is bigger than 0. So therefore, we have real, because it's bigger than or equal to 0, and because it's bigger than 0, we have real and distinct roots. So that is the proof. So we just want to prove that the discriminant is bigger than or equal to 0 for all values of k. And we can see that from this equation. All right. So that is question 9. Let's go to question 10. And it's essentially the same question. Prove that the roots of this equation are real and distinct for all real values of k. All right. K minus 2, that is b squared, minus 4, a is 1, c is minus 2k. So that is the discriminant. And if I simplify, I get k squared minus 4k plus 4 minus 8k, that is plus 8k. So I have k squared plus 4k plus 4, and you can actually write this as k plus 2 whole squared, right? And if you look at this from a translation perspective again, k plus 2 just means that the graph has shifted 2 units to the left, right? So if it's x squared, or if the graph of k squared looks like this, then you have just shifted it 2 units to the left by adding 2. So this expression is bigger than or equal to 0 for all values of k. Whatever k you put in, so this just means for all values of k, this expression is bigger than or equal to 0. So for all k, we have real roots. I wouldn't necessarily say they are distinct roots, because if you substitute k is equal to negative 2, so x squared minus 4x plus 4, right? If you substitute k negative 2, then you only have one root, actually. That is x minus 2 squared. So you only have one repeated roots. So they are not distinct, but we always have real roots here. So we can guarantee that this equation for all values of k has real roots, but for k is equal to negative 2, right? Which is a real value, we have one repeated root. So we don't have distinct roots for 10, actually. We can have a repeated root, or we can have distinct roots. So if k is equal to negative 2, we have repeated roots for 10. If k does not equal to negative 2, any other real number, we have distinct roots. All right. And finally, we can move on to question 11. Sorry, let me just put that on the screen for here. All right. Now we can move on to question 11, the final question. So we have this equation. So we want to prove that this equation has real roots if k satisfies this condition. And for which other values of k does this equation have real roots? So we want to check the discriminant again, b squared minus 4ac. So that is k squared minus 4a is 1, c is just 2. And that is equal to k squared minus 4 2s are 8. And remember, 8 is just 2 cubed, right? 8 is 2 cubed. And I don't want to write this as a cubed term, actually. I wanted to write it as a squared term. So how can I write this as a squared term? Well, I can say that 2 is just square root of 2 squared, right? That is 2 cubed. And I can switch the position of my indices. So I can say k squared is actually square root of 2 cubed squared. All right. X squared. And the square root of 2 cubed is just 2 root 2 squared. And now I can write this as k by using the difference of squares. K minus 2 root 2. A plus b, a minus b. So now, if k... Now you can sort of write this, right? You have... If I put minus 2 root 2 and 2 root 2, and you know plus minus plus, by using the ideas of inequality. So if k is bigger than or equal to 2 root 2, then we have this inequality bigger than or equal to 0. That is the condition for real roots. The discriminant has to be bigger than or equal to 0. So if it's equal to 2 root 2 or bigger, then that satisfies. But the condition is also satisfied when k is less than or equal to negative 2 root 2. So you can show that any value, positive value, that is greater than or equal to 2 root 2, that satisfies. And this is the extra value. So for what other values of k? If k is less than or equal to negative 2 root 2, then you also have real roots. So that is the answer for 11. And that is it for this topic.